Where's the leader? Do you have checked with that? Only these people. How many people? Ni je ke? Biasanya ramai lagi kan? Foreigner berapa orang? 5 orang kan? The rest is okay. Tahun 30. Oh ya, betul. Correct. Cepat, we are going to start now. Alright. We are going to start the class, so I think it's better to have the class here because you can do practical directly. Rather than in the class, I don't think so you can understand most of it. Okay, we start. Last lecture we already started to play around with the code. Alright, that one is they call it assembly language. We are going to use assembly language. First year, you are using C++ or C? C++. That language is C++ language, where that is a high level language where you can understand most of the instructions. Here, in assembly, the instruction or syntax is different. You have to go deeper, down, another layer. So you can program your CPU. You can program the whole set. Alright? Remember that when you do any programming, you have to compile your program, correct or not? What's the purpose of the compile? It's a normal answer, that one. Normal answer, yes. This is what normal answer. I didn't say Ross, I didn't say. But it's a normal answer. Why you need to compile is you want to find the syntax error. Correct or not? You want to compile, you want to see the error, correct? It's correct. The whole thing. But the concept is one thing is you need to compile is because you need to convert the language to the machine language. Because your machine do not understand the whole C. Your machine cannot understand assembly language like we understand. The machine will only understand 1010100010. That's all. That's what they understand. So when you do the compilation of your program correct, you want to see whether your program is correct or not. Okay. But normally you cannot debug the flow of the program by using only the compiling system. You need to debug one by one. So the basic things, the main thing is you want to compile, is you want to make sure the whole code is correct. Then you convert it to the machine language. Then you can use it. Okay? So that is a machine language. Have you ever heard about a movie called The Matrix Trilogy? That is not your zaman kan? Keanu Reeves. It's a 1990s movie. It's a trilogy movie. The Matrix Reloaded or whatever Matrix. That is related to the computer system. It's a science fiction movies. They are always show the numbers is 10101010101010. Okay, that is the Matrix, the Matrix trilogy. I recommend you to watch that one if you are a science com people, if you are a programmer. That is the movie that you can watch. It's very entertaining movie, and it's a very, very technical movie. Okay, let's move. One, you know about the machine language. Assembly is the one that we are using for this coding. Last time we were using the move.byte app.something. We are going to use it today. Alright, that is the assembly language. Assembler is the software that translates the language from assembly to the machine language. The compiler, they call it also. The assembler, they call it also. Same thing. The function, that's why the function is to convert or to translate the language that you are using to the machine language. Because the machine cannot understand us. They understand machine code sahaja. And we do not understand their code, but we can understand how we can convert to the code. Alright? So that's the assembler. So this is the process last time. Remember that when you do programming, you assembling, you do see syntax error, then you can execute. Semantic error is about the flow program. That's another thing. Majority is all about the syntax. When you compile it, you have to make sure that you can use it. And then later you can use semantics programming or semantic debugging. Alright, next. This one can be later can be done by Mr. Bazli because this is under the project. Okay, this is example. If you look at this example code, you don't understand, correct? This is assembly language. This is the whole assembly. When you do programming for your final project and not final project, your project for the semester, this is the language that you are using. In the beginning of the semester, you don't understand all. But for the first 6 weeks, you are going to learn majority of the syntax. Because this is not as easy as C++, where you can write down if this one, then do this one. Else if, do this one. Go to that. You see here is different. You can add, you can subtract, you can BNE, you can move, blah, 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 blah. You don't really understand it. But that's why you need to learn the code first before you proceed for the final semester of your project. Okay, so far okay? Okay, next. This is after you compile. I'll show you this one when you do the compiler. This is the object file. This is actually the machine language basically. So Mr. Bazli has to proceed with this one. Alright. We start on the coding. So last lecture we start the coding already, right? By using add.byte. You remember that? Okay. You open up your PC68K right now. When you start up your PC68K, when you start your PC68K, they will give you a template. A template. If you see the template, basically there are 4 sections invisible. 4 sections means that you have the first tab here. Remember that I just asked you first time to tab first, tab, and then you can write. And then you tab again, you write. There are 4 sections basically. So one here, this one don't care. You one here, and the green color here, and another one here. And the last one is this semicolon. Semicolons, normally you want to comment out the line. You don't want to care. You don't care. You just put a comment or whatever. In C++ also have, right? What do you put comment? Slash. Slash and star and asterisk kan? Just slash saja.
Double slash.
Double slash. That's a commenting out. For CPU code, we are going to use semicolon to comment. Right? So there are 4 sections. The first section is label. The second section is operation code. The third one is the operand. The last one is comment. Comment is up to you. You want to comment what? For the programmer, normally we have to do our own comments. Why? Because you don't want to get lost. Or maybe you have a lot of projects, like you have when you're working, right? You have maybe 4 to 5 projects which requires you to do programming. That program contains thousands. I just say hundreds of lines. When you do another project, you forgot that one already, right? So that's why you need to put comments by your own, so that you can understand. Comment is just a comment for you normally. So we are trained to do that. So make sure that later, if you are doing your own project, you can comment a lot of lines, up to you, to make sure that you don't get lost. Because we cannot store all the memory inside our RAM over here every day. They will not go to be ROM anyway, they will go to be delete. Our RAM also going to be deleted soon. I also cannot remember all my program. I open up and I have to read back. Okay, so we are the concept of this. Okay, look at that one again. So you have the label. You have the label at the first step here. Then after that you have the operation. You have the operand, and the last one is a command. And all should be color coded. Color coded means that to make sure that you try not to have a lot of syntax error. Same like your C++, all color coded, right? So it's much easier. You know that this color should be like this. So if you do something else wrong syntax, the color will be changing. So that's to improve anything about the syntax error, right? Let's go. Okay, now that is the one. This is the one. Again, you have the label, you have the opcode, you have the operand, last one, optional commands. So this is a term. Just remember the term. Benda-benda baru is a term that you have to digest. You cannot ask anymore because it's a name. Name you have to accept. Okay, it's a term. Terma. So this one I'm going to teach maybe next week. Because we have to go for the command first, then you understand this. Okay, let's look at this command. This one skip first. Okay. The command we are going to learn, basically there are 8 areas. Today we are going to use only data transfer and maybe arithmetic a bit. Data transfer is the most easiest one. So you understand that one, then we have to go one round. Right? The rest, this is getting tougher. This is getting tougher, this is getting tougher. This is easy, this is getting tougher. Tougher and tougher. Right? Next, data transfer. Data transfer. So let's look at the concept of data transfer. Okay, the first one we are going to do it today is to transfer the data between register, which is data register to data register. The command is very simple. The command is move. Move, you just move the bit anywhere that you want. But here is the topic for data register direct. So what does it mean? You are going to move the data between the registers. Data registers only. So inside your CPU just now, you have total of 8 data register. Remember that? You have 7 address register. So for this command, we are going to play around first data register first. So the first one command example, move.long D0 to D2. What does it mean that long is how many bit? 32. Long is 32 bit. So you are going to move the whole 32 bit from D0 to D2. This is the short form. D0, whatever the contents of D0 is going to be transferred or copied to D2. So that's why it's move.byte. Move.byte D0 to D1. Byte is how many bit? 8 bit. So you are going to move or copy only the first 8 bit from D0 to D1. Okay, so far? D0 to D1 means that there are 2 registers, D0 and D1. Next one is add.long. D0, you are going to add the data inside D0 with data D3 registers, and the final answer will be saved over here on D3. Clear.byte D2, you are going to clear anything in the data register number 2 for byte only 8 digits. So if you look at this table, The command is only applicable for data register only. D0 or D1 or D2 or D3 up to D7. Okay, that is the meaning of data register direct. So let's try now on your 68 easy 68 KQ. We are going to do that. Turn on your PC, already turn on. So write down this one. Okay, write down the code. I give you 5 minutes to write down the code. So that's why you are not getting sleepy. If you are using this one, you are not getting sleepy. If I only talk at the front, work in a group, work with your friend, try to understand. So we are going to play with the command for data register direct. We are going to do for the data register, move data inside the CPU between registers. For this compiler, use Origin 1000. Don't use another thing. You just use the compiler Origin 1000. Just use it. Then you can trace one by one. Look first your result before I you try to figure out the result. What happened? What do you think? Most of you already see the result. You have to execute and run by one. Run one by one. See the result already? So we are going to explain it first.
Lama dia.
Let me show you the results. Is it the same with me or not? So I think this absolute number. So that number is going to be moved to D0. Correct or not? Is it correct? Alright, the next instruction is move the along this number to D1. Is it correct? Yes. Alright. Now, we are going to do the movement from data register to data register. From D0 to D3, we are going to copy the value from D0 and D3 in operation of long word, 32 bit. So if I run this one, I'm going to take the whole 32 bit from D0, copy to D3. Agree? The next command is also move the along from D1 to D3. So that figure from D1, the whole 32 bit will be transferred or copied to D3. Currently, there's a value inside D3. It's going to be erased. So I run another one, erase, correct? Yes.
Why the value of D0 to D3 is not the same?
Why D0 to D3?
When we move D0 to D3, what is this value? What is 11.2554?
Just now, I already moved it. This is the last command. This is only erase.
Remove the first one.
Sorry?
Remove the first one.
Yeah, erase.
The first command.
Yes, it will erase. The command is what, when you do programming, the command will execute from the top to bottom, right?
So what is the value of the first one? Move the head. Move the head D0 to D3.
This one. Move the L D0 to D3. If I erase this one, yes, you will get again what is this one? This is no, this is to show. This is not your program. This is to show the program how it works. Just to show you what happened. That's all inside the PC. Yeah, I can delete. I have no problem with deleting it. Not to be said, I don't. It's just an example. I mean, I can put anything. I just want to show how it works. Yes, I understand what you're trying to say, but the thing is, there's no harm to show this one. There's no harm. All right. So bear with it. So now, okay, now change. Okay, since that we have some questions over there. So okay, let's change this one to D4. This one change to D4. And now you change this one to byte. Change this one to double. Yeah. You want to see the difference, I mean. This is all basics. So I just change it. I want to show that what happened. The thing is, you need to understand what is the code saying. What is the meaning of the coding? Wrong. red color arrow. That's to rewind. Rewind and redo again. Conclusion from that basically. If you are using dot long, you are going to take the whole numbers, right? It's 32 bit. If you are using word, you are going to take only 4 digits in hex because it's 16 bit. Right? Correct? If you are only use byte, only 2 digits will be moved or copied. So that is the functions of dot long, dot word, dot byte. So far okay? So this operation is inside the data register in your CPU. Okay, now look at this one. A lot of people seems like very curious on this one. Okay. A lot of people curious. This is very good information basically. You're going to learn anyway. Alright, look at here. This is your code, correct? Yes. This is your own code. This is assembler. This is assembly language. This is your line. So means that if you have a syntax error at line that one, try to figure out which that line got problem. Okay, here. Here is what and here is what. The first one, this one is actually your memory. So remember that every time you want to have your program works, you have to store the machine language to the memory. Have you ever worked with Arduino? Arduino, you need to upload the program to the system, right? To the ROM. Basically, ROM is just like memory. There's a locations of it. Inside that ROM is a particular area where you can reserve, where you can save the program. Same like this. This is simulator. This is simulator. Simulator, I put 1000 because I just want to put over there. So means that inside my memory. So my